Hey everyone, welcome back. We are picking up on reviewing the syllabus from the College Board for AP Calculus AB. So we're picking up roughly where you'll be when you start semester 2. Of course, it depends on the specifics of your course. But this is Unit 6, and this is where we really start to learn the idea of the antiderivative or integration. So semester 1 roughly is attributed to understanding the derivative, the concepts of slope, and then second semester is typically learning how to take the antiderivative. So almost learning how to go backwards from everything you just learned in semester 1, and also conceptually what that means. So oftentimes this will be introduced by talking about really accumulation of change, as an example, like total distance traveled, something like that. The first technique you learn to approximate the integral, which is effectively the area under the curve, is the Riemann sum. So basically, you will learn how to really split up the area under the curve into a familiar shape. Usually you start by learning rectangles. Sometimes you'll also learn trapezoids. And then from there, you'll basically learn how to really just use the formula for the area of a rectangle and add all of those areas together to approximate the total area under the curve. So that is basically Riemann sums. Next, you will learn the fundamental theorem of calculus. And then, of course, you will again revisit this idea of accumulating, right? So the accumulation functions, in this case, involving area. You will also learn the properties of the definite integral. So you have kind of these two high-level ideas. You have the definite integral and then the indefinite integral. Definite integral has set boundaries, so going from A to B, and then indefinite integrals, you just come up with an equation, but it doesn't have set boundaries. Here we go, the FTC, Fundamental Theorem of Calculus, and definite integrals. And then here we go, so finding antiderivatives and indefinite integrals, which is kind of what we were talking about. And this is just introducing basic rules and notation. Then you will also learn certain techniques that will help you with integration, such as substitution, and then also how to integrate functions using other techniques such as long division or completing the square. All right, moving on, Unit 7. This is where you really just look into differential equations and analyze them. So 7.1 is modeling situations with differential equations. So this is really focused on really just modeling these equations that we've been looking at. Oh, you will also be introduced to slope fields, which is basically just literally just a graph of slope. I'm vastly oversimplifying that. I can do a more in-depth video on that later. All right, moving on. And I guess I didn't really make that clear, but this here is an example of a differential equation. So it's just something that gives you, for example, like dx dy or dy dt. That's a differential equation. Okay, here we go. Okay, good. And then Unit 8 is applications of integration. So why do we care? Why do we even find the integral in the first place? So here we talk about how we can use it to find the average value of a function, also how it can relate to position, velocity, and acceleration functions, which we also talked about in semester 1 with the derivative. Now we're talking about how the integral can relate to those and be applied. And then, of course, again, we see this idea of accumulation, right? So how we can use the integral to find the accumulation of an amount. And then finally, now we're looking at how to use the integral to find the area between two curves. So up until now, we know how to find the area below a curve, but now we learn how to find the area between two curves. Similarly, we also introduced the idea of volume. So basically how to get the volume of different solids using cross sections. And then, of course, this is more volume. So volumes of revolution using the washer and disk methods. And then that's pretty much it. So basically, just to give you a quick little recap, semester 1, again, is the derivative slope. Semester 2 is antiderivative, integration, and finding the area under the curve. Thanks so much for watching.